Every Wednesday. Today we are talking about compound interest a little bit more. Yay! We're going to talk about Rule of 72. We're going to talk about present value and future value formulas. Okay, so this unit is just a lot of formulas that we're going to plug in. But at first, we're going to watch this lovely video. Yeah. But first, a commercial. No commercial. There you go. What would you do? Well, those are your option one, option two. Okay. Yeah. So majority of you said option two, like initially, right? Okay. Option one was a better one. And that's because they invested earlier. So if you can do like, even if it's like 500 bucks when you're like 20, okay, that's going to make you a ton of money compared to if you wait until you're 30 and then you start investing. Okay. Everybody good? All right. So was the conclusion from the video surprising for you? Why not? And obviously y'all said, hey, option two, right? Okay. What products or things around us are affected by compound interest? What products or things around us are affected by compound interest? Do we know? No? Okay, so the rates impact compound interest. The rates. Okay, so depending on like what you are investing in, sometimes this is decided by the feds, sometimes this is decided by the bank, sometimes this is decided by where, like, however you're investing that money. Okay. All right. So we're going to take a moment. I want you to explore, what do these words actually mean? Okay. So you're going to take a couple minutes and I want you to answer, what are these questions? Okay. We've kind of talked about most of them, but I think we kind of forgot a little bit. But I want you on your paper to define what is interest, what is a principal, what is an interest rate, what's simple interest, what's compound interest. Yes, you can use your laptop if you need to. If you want to go back to your notes, because we did talk about this in unit 1 and 2. So go ahead and take a moment to find those words. Okay, what did you get for interest? Okay, what did you get for principal?
The amount of money you invested.
Initial amount that you invested. Okay. All right, what about interest rate? What did you come up with? Amount change on top of the principal. Okay. What is simple interest? Interest on principal only. Okay. And then compound interest.
Yes, on both principal and interest already paid.
Okay. Simple interest is what you want to use when you're purchasing something. Compound interest is what you want to use when you are investing money. Does that make sense? Because it's compounded over and over and over again. So you're making money off of the money that you've already made it. Like the more it grows. Okay. Remember, compound interest has like it's weekly, it's monthly, it's yearly, all those little LY words. All right, so we're going to fill in the table to answer the following problem. What is the difference between simple and compound interest? We will use an initial investment of $1,000 and an annual interest rate of 5% over a period of 5 years to see the difference. Okay, so just a refresher, simple interest, that formula is P plus P times R times T. Okay, P is your principal amount, R is your rate, and T is the number of years. Okay, for compound interest, we're going to use this formula. They didn't tell us like weekly, monthly, etc. They said annually, right? So that's one time a year. So remember, compound interest is going to be P times 1 plus R raised to the T. Okay, so what I would like for you to do is take a moment, go ahead and fill in the first 5 years. Okay, so go ahead and fill in the first 5 years. All right, simple interest. Remember, that's you're multiplying the principal times the rate times the time, and then adding it to the original principal. Okay, so for simple interest column, you should have got 1,050, then 1,100, and then 1,150, and then 1,200, and then 1,250. Right? Okay, you notice how this is going up by a consistent amount? Okay, it's linear, right? Yeah. Now, on the compound interest, a little different. It's 1,050, which is the same as the simple, because that's year 1. Okay, then it's 1,102.50, not too big of a difference. The next year, though, we get a little bit more. The next year, a little more. And then the next year, a little bit more. There's not that big of a difference. Sorry. Okay, there's not that big of a difference. But if you invest more, you're going to see a bigger difference. Okay. We only invested $1,000, but I'll take the extra $26 that I get here. That'll buy me a couple of Chick-fil-A sandwiches, right? No, no, yes. They're like $10, right? Chick-fil-A sandwiches. Y'all lame. Y'all don't know how to like calculate things in Chick-fil-A sandwiches. So sad. Okay, so let's go ahead and look at the next page. Okay, rule of 72. Okay. My dad is actually a real estate agent, or used to be. He's now retired. Thank the Lord. So he always talked about the rule of 72. I really didn't know what it meant, but Now I do. Look, turtle shell's coming back. That's 5 videos this week. By the way, when you buy a house, they have to do like a credit check and then they run numbers. It's $20 to $30 for them just to run your like credit and run like a formula. Just FYI. So that's mm. Okay. So, rule of 72. It's just kind of like a formula to help us determine how long it's going to be to double your money. Okay. So, to double money, double, my pen has been tripping. I'm so sorry. Money, you take 72 divided by the interest rate. Okay. So, how much of a difference does a higher interest rate make? So, rule of thing. If you are getting a house, you want your interest rate to be lower. If you are saving money, you want your interest rate to be higher. Okay. So you've got to pay attention to, are you saving money or are you spending money? Okay. Interest rate lower if you're spending money. Okay. So really quick, what I want you to do is take 72 and divide it by the interest rate. Okay. And that's going to figure out the number of years until the investment doubles. So if we take 1,000 and we take 72 and divide it by this interest rate, okay, what does that give me? 72 divided by 2 is 36 years. Okay, so if you put in $1,000 in 36 years, you'll get $2,000. Okay, what about 72 divided by 4? What does that give me? Huh?
16.
16 years. That's a little bit better. Okay, 72 divided by 6. Okay, 72 divided by 8. And 72 divided by 10. So wait, 2 years. And then 72 divided by 20. And 72 divided by 40.
120.
Okay, here's the deal though. If you are putting in savings, I don't think I've ever seen anything higher than like 4 to 8% interest. Okay. But like, let's say you invest $10,000. I mean, I can wait 9 years to make it 20,000, right? If you invest 50,000, I can wait 9 years to make it 100,000. So it sounds better the more you're investing. Yeah. If you invest little, you're not getting as much. Yes, ma'am. 1% is 18. Y'all lied to me. 18. I said 16 or 18. 72 divided by 4. Okay. I just wrote 16. What I heard. It's fine. All right, good. Boom, boom, boom. All right, so far, you've investigated two factors that influence compound interest rate and the investment durations. So the years that isn't years given to grow. There is yet one additional factor that influences compound interest, and that is compounding period. So what is a compounding period? That is how often the amount is compounded. Okay, so remember we talked about our LY words like weekly, monthly, yearly, semi-annually, quarterly. Okay, LY words are called adverbs. They describe how often that something occurs. Okay. So what are examples of compounding periods? Well, I just put these on the side. Sorry. So weekly, monthly, yearly, all that jazz. Go ahead and fill those in. Do we remember how many is semi-annually? 2. Quarterly is 4. Monthly is 12. How many weeks are there? Okay, and then daily, 365. I'm gonna be honest. When you're saving or you're investing in something, it normally doesn't happen daily. Sometimes that'll happen monthly. That's probably your most frequently used thing. Weekly is probably not a reasonable thing. That would be awesome, but it does not happen. All right, so in order to see the difference between these 4 compounding periods on an investment, we need to introduce another formula to allow you to do the calculations. You've already seen this. This is from Algebra 1. We also use it in Unit 1. Okay, here are all of those things defined. So your amount of money, the initial balance, the interest rate, the number of times interest is applied per time period, and the number of time period elapsed, typically in years. Okay, so now using the formula above, calculate the final amounts for this scenario. You've got $1,000 investment at 5% for 5 years, for 10 years, for 15 years, for 20 years, looking at 4 different compounding periods. So annual, quarterly, monthly, and daily. Okay, so what you're going to do is you are going to take this formula and plug in your information. P is 1,000. 5% is 0.05. That's your R. N is whatever number's up here in that column. And then P is whatever number is in that row. Okay, so you're going to fill in each box. Okay, I want you to take a couple of minutes. I want you to try this one on your own. You have to be able to do compound interest by the time you leave my class. Okay, so try to fill in those. I don't know why I said aggressively. All right, so when you plug all this junk in, Okay, remember, you're using the formula. You have to make sure that you understand how to use the formula. You should have got 1276.28. You should have got 1628.90 and 2078.93, 2653.30. For the next one, 1282.04 and 1643.62 and 2107.18 and 2701.48. Monthly 1283.36, 1647.01 and 2113.70 and 2712.64. Daily 1284.00 and 1648.66, 2116.89 and 2718.10. Yeah. Questions on that? And you can get all those numbers. You got to be able to do compound interest. Okay. Okay. So in finance, the amount of an account is worth after a set amount of time and a constant interest rate is known as a future value, FV. The current principal of the asset known is present value, PEV. Business professionals in finance rewrite the compound interest formula by replacing A with FV and P with PV and R with I. Solving for PV makes finding the principal for an event more efficient. Okay, so it's the exact same thing as compound interest. We've just changed the words a little bit. Okay, so the time value formula can be useful in capital budgeting, valuation of companies, loan amount, and annuity calculation, insurance premium calculation. My brother uses this a lot with life insurance stuff. Okay, so let us assume that a sum of money, say 100,000, is invested for 2 years at 8% interest rate. What will be the future value of the sum invested? So we're going to find the future value. So we're going to do this guy. So future value is equal to, how much is it right now? 100,000 times 1 plus 0.08. And we're going to divide it by 1 because it's happening for annual, right? And we're going to multiply that 1 times 2 in the exponents because we're doing it for 2 years. When we plug in all that junk, we're going to get 116,640. Okay, so notice how in 2 years we just made $16,000 more. Yeah. Let's say that Josie borrowed some amount from a bank at a rate of 5% per, I'm going to mess up this word. This is just annual. It's just the direct object. That's just a different way to write it. Compounded annually. If she finished paying her loan by paying $4,500 at the end of 4 years, then what is the amount of the loan that she had taken? Round your answer to the nearest hundreds. So on this one, we're trying to work this problem backwards. So looking at the formula for PV, looking at that formula for PV, so PV equals FV, and we're going to divide it by 1 plus I divided by N raised to the NT. Okay, so for PV, what's our future value? Future value was 4,500 divided by 1 plus 0.05 raised to the 4th power. So if we calculate that, that's going to give me $3,702.16. That's how much she took out at the very beginning. Can you try number 3? What are they asking us to find? Are they asking for FV or PV? What was the amount invested? So we're looking for PV. So you're going to use the PV formula, okay? All right, so go ahead and take a moment, plug that in, and tell me what you get. 2 seconds. All right, so I plugged in all my numbers. Remember, it says daily. So instead of that N being 1, it's going to be 365. So for 10 years, okay, so we're going to plug in 10 for T. If we plug all this junk into our calculator, we should have gotten 1,000.81. Okay. Questions on that one?
Oh.
Good. Okay, the biggest mistake that people make is they don't change the percent to a decimal, or they ignore one of the LY words. Okay. These parts of these problems, you've got to make sure that you read and kind of like underline the adverb. Okay. Everybody good? Yay. So go ahead and I want you to think about these 3 questions. What advice can you give to other students about pros and cons of the rule of 72? Okay. And then what is the difference between simple and compound interest? And then what are 3 things that influence a compound interest account? Okay, take a moment, answer those 3 things. You can talk to a neighbor about it. And then we're going to move on to the next part. All right, so what advice can you give to other students about pros and cons of Rule 72? Not the exact time, but pretty close, right? Like, again, guidelines, right? What's better about the Rule of 72? Like, what makes it better for you or worse for you? Huh? Say it again. Okay. So the higher the interest rate, what happens? Higher the interest rate, more money saved. Remember, the rule of 72 is talking about the number of years, right? So the higher the interest rate, the less amount of time it takes you to double, right? Okay. What's the difference between simple and compound interest? Okay. So with compound interest, you got those LY words, right? Daily, weekly, monthly, etc. With simple interest, it only happens once a year. Okay. All right. What are 3 things that influence a compound interest account? The interest rate, the number of years. What else? Interest rate and your principal balance. You can invest 1,000 or you can invest 10,000, right? All right, good. All right, let's go ahead and move on. I want to get a little bit of practice with this one. Go ahead and join. We're gonna play Among Us. Yay! So it's only fun if you actually join.